Welcome to Module 13 in the series of 14 modules on the Fundamentals of Telecommunications. The topic today is on information security. Once again, I'm Ted Chandler, your CIS online instructor. After completing this module, you will be able to first list the key steps in assessing information security risks. Then you will be able to explain the elements and purpose of a security policy, describe the strategies for minimizing common security risks associated with people, passwords, physical security, and modem access, discuss the most popular current methods of encrypting data, identify security threats to public and private telephone networks and discuss ways to prevent them, identify security threats to LAN and WAN-based telecommunications and discuss ways to prevent them. And finally, you'll be able to discuss security threats to wireless telecommunications and discuss ways to prevent them. In a risk assessment, an organization analyzes its valuable assets, ways in which the assets might be compromised, the sources of threats to those assets, and the consequences that would arise if those assets were stolen or damaged. Data gathered from a risk assessment is used to generate a security policy. The more an organization has at stake, the more time and money it should invest in security precautions. A risk assessment should answer the following questions. What resources or assets are at risk? What methods could be taken to compromise those resources? Who or what are the most likely threats to those resources? What is the probability that the organization or its resources will be compromised? And finally, what are the consequences of those resources being compromised? Key goals of a security policy include: first, ensuring that authorized users have appropriate access to the resources they need. Second is preventing unauthorized users from gaining access to facilities, cabling, devices, systems, programs, or data. Also, protecting sensitive data from unauthorized access from individuals both internally and externally to the organization. Preventing accidental or intentional damage to hardware, software, or facilities, creating an environment in which network and its connected nodes can withstand and, if necessary, quickly respond to and recover from any type of threat. Now, to be effective, an organization should appoint a security team and involve technical and managerial personnel in developing the security policy. Among other things, the team communicates with each employee's responsibilities with respect to maintaining information security. Part of the security policy, the response policy, describes in details a planned response to possible security breaches. It also should identify members of a response team, all of whom clearly understand the security policy, risks, and measures in place. The most significant network security threats come from people inside an organization, whether due to human error, ignorance, or omission. The number one method for an intruder to gain access to a network is to simply ask a user for his or her login ID, password, authorization code, or to request entrance into a secured equipment room. This technique is known as social engineering. Choosing secure passwords is a simple way to augment information security. Secure passwords are as long as possible, contain both numbers and letters, and if allowed, special characters, are never shared with anyone, change frequently, can never be found in a dictionary, or do not represent a date or word significant to the user or organization, and never equal the default password established by a software program upon installation. In a highly secure environment, Access to equipment rooms, telecommunications closets, cable vaults, demarcation boxes, and even work areas is restricted to only those who need to gain access. Questions to ask regarding physical security include: which rooms contain critical systems, transmission media, or data and need to be secured? How and to what extent are authorized personnel granted entry? Are security methods such as ID badges difficult to forge or circumvent? Do supervisors or security personnel make periodic physical security checks? And finally, what is the plan for documenting and responding to physical security breaches? Modems are often an easy way for hackers to access a network. At greatest risk are modems attached to workstations with no firewalls or other devices between the network and the outside world. Encryption acts as the last means of defense against information eavesdropping, theft, or tampering. In other words, if an intruder has exploited all of the means of entry, including physical security and password security, signals can still be sent secure if they are encrypted. The most common used form of encryption on modern data networks is key encryption, in which a string of characters is interleaved with the bits of data that make up a message according to a predefined algorithm. In general, the longer the key, the more secure the encryption. Private key encryption requires both the sender and receiver to know the sender's private key. Kerabosis, a cross-platform authentication service, uses private key encryption. Public key encryption uses a combination of a private key known only to the recipient and a public key available from a public key server. Encryption methods include Kerabosis, a cross-platform authentication protocol that uses key encryption to verify the identity of clients and to securely exchange information after a client logs onto a system. PGP, which is Pretty Good Privacy, is a public key encryption system that can verify the authentication of an email sender and encrypt email data in transmission. IPsec, for Internet Protocol Security, defines encryption, authentication, and key management for TCP/IP transmissions. And finally, SSL, for Secure Sockets Layer, is a method of encrypting TCP transmission between a client and server using public key transmission technology. Hackers can easily eavesdrop on telephone conversations in a home or office, at the demarcation point, elsewhere on the local loop, or at the equipment in the LEC's, local exchange carrier's, central office. Modern wiretaps are difficult, if not impossible, to detect. To be considered truly secure, voice signals should be encrypted before transmission. Private telephone switches, such as PBXs or private branch exchange, are frequently targets of security attacks, such as toll fraud, denial of service attacks, and information interception. Or they may be used as stepping stones to compromising a data network. For optimal PBX security, administrators should disable the DISA feature, limit access to the maintenance port, require long, difficult-to-guess authorization codes, configure the PBX to limit certain incoming and outgoing calls, and finally separate the PBX from the data network. Voicemail allows callers to leave messages for later retrieval and is a popular access point for hackers. For optimal security, administrators disable unused voice mailboxes, enforce security mailbox passwords, keep voicemail system access numbers private, and monitor voicemail usage for suspicious behavior. Telecommunications firewalls offer a sophisticated, centralized way of selectively blocking incoming and outgoing calls. They are typically placed between an organization's PBX and the lines or trunks that lead to a LEC central office. One way of limiting access to a network's resources is through the network operating system. Administrators can limit user file and directory rights, as well as the time of day, place, and length of time that users can log on to the network. Network security can be improved through better design. Consider restricting access to transmission media and separating private and public hosts using a firewall, switch, or gateway. Note areas of the network that share a broadcast domain, in the case of Ethernet, where all traffic can be captured by nodes that share the same channel. Use gateways or proxy servers to mask private IP addresses. For the best security, encrypt data in transit. A common type of firewall is a packet filtering firewall, which is a router that operates at the data link and transport layers of the OSI model. It examines the header of every packet of data that is received to determine whether the type of packet is authorized to configure to continue to its destination. And also, packet filtering firewalls must be carefully configured to be sufficiently restrictive, yet allow valid traffic to pass through. Proxy servers or gateways is the network host that runs the proxy server. Proxy servers manage security at all layers of the OSI model. And on a network, a proxy server is placed between the private and public parts of the network. Proxy service is a software application on a network host that acts as an intermediary between the external and internal networks, screening all incoming and outgoing traffic. Virtual private networks, or VPNs, typically use the Internet, PSTN, or both of these public networks to connect multiple sites, which leads to significant security risks. VPN take advantage of firewalls and special protocols such as PPTP, LTF, and LTTP that encrypt the data transmitted over public connections. Cellular telephone signals are subject to eavesdropping, but in CDMA and TDMA-based transmission, signals are multiplexed and encrypted, making interpretation more difficult. Cloning cellular telephones, a practice in which a hacker obtains the phone's unique identifying number and then copies that number to his own phone service, presents a significant security risk. After the hacker has created a clone, he can use the phone for toll calls without raising suspicion with the cellular carrier. The user will not know about the breach until she or he receives his or her cellular telephone bill. Wireless LANs rely on secure network design and unique wireless encryption techniques, such as the wired equivalent privacy, or WEP, to safeguard information in transit. However, WEP is notoriously easy to crack, and IEEE committees are developing better wireless LAN encryption techniques. The Extensible Authentication Protocol, EAP, can be used with WEP on wireless networks to improve wireless LAN security. EAP operates at the data link layer and specifies a pre-authentication process in which a client and server exchange data via an intermediate node. Only after they have been mutually authenticated can the client and server exchange encrypted data. In summary, we have covered the following main points regarding network security. First, in a risk assessment, an organization analyzes its vulnerable assets, ways in which the assets might be compromised, the sources of threats to those assets, and the consequences that would arise if those assets were stolen or damaged. Key goals of a security policy include preventing unauthorized users from gaining access to facilities, cabling, devices, system programs, or data, and preventing accidental or intentional damage to hardware, facilities, or software. And finally, encryption acts as the last means of defense against information eavesdropping, theft, or tampering. This completes Module 13. Please take Quiz 13, and I'll see you in Module 14, the last module in the series of 14 modules on the fundamentals of telecommunications.